Before us is a very simple diagram. This is just a benzene with some water, and right here we are looking at probably a log, something wooden. This wooden solid substance is floating on top of this water, as you can see. So now, as this is floating, we all know, or it should be common knowledge, that anything that floats on top of a liquid, it does so because it is less dense. For example, in this case, we are having this water and we are having this solid mass. This solid mass is able to float on water because its density is less than the density of water, or in other words, it's less dense than the density of this water. However, for the solids that, or substances that are able to sink in water, they are able to do so because their density is greater, or it's more than the density of water. So let's concentrate on the floating thing. For those substances whose density is less than the density of water, and as a result, they float. This thing, while it is floating, as you can see, it is digging itself into the surface of this liquid. In other words, what I'm trying to say is that a portion of this substance is embedded in the surface of the liquid, and part of it is exposed on top. Now, of course, this portion that is into the surface of the liquid, in doing so, it displaces some of this liquid. Some of this water is displaced as a result of this floating body. So what does that mean? It simply means that all bodies that float on water, there is a certain amount of liquid they displace, so that, in other words, some part of it is exposed up and some other part is displaced. Some other part of the solid displaces some liquid. And in today's video, we are concerned about that liquid that is displaced. That liquid that is displaced is definitely equivalent to the volume of that portion that has displaced it. But if you get that liquid that has been displaced and you probably weigh it, the weight of that liquid that has been displaced by a body that is floating is equivalent to the weight of the entire body that is floating. And that right there, ladies and gentlemen, is what we are calling the law of flotation. In other words, the law of flotation simply states that any floating body, or a floating body, will displace its own weight of fluid in which it is placed. So let's take note again that a body will only float in a liquid if its density is less than that of the fluid in which it is placed. We should also take note that the weight of a floating body is equal to the weight of the fluid it has displaced. That is what the law says. But the volume of the body that has been submerged, remember, as this thing is floating, it is just a portion of its volume that is submerged. So the volume of the body that has been submerged is equal to the volume of the fluid that has been displaced. And of course, the mass of the floating body is equal to the mass of the fluid that has been displaced. So we'll go ahead and do some examples that require us to use the law of flotation in our interpretation. Right here we have a cubical block of steel, 12 centimeters on each side, is floating on mercury in a vessel. The density of steel is 7,800 kilograms per meter cubed, and that of mercury is 13,600 kilograms per meter cubed. What is the height of the block above the mercury level? Let's summarize this question with a diagram so that we get a clear picture of what we are up against. 12 centimeters, meaning that every side is 12 centimeters. It's a cube. It is floating on the mercury in a vessel. So this thing is in a vessel, and the liquid it's floating on here is actually mercury. Now the density of steel is 7,800 kilograms per meter cubed, and that of mercury, of course, the density of mercury is 13600. What is the height of the block above the mercury? So let's say this is where the mercury cuts. All this is mercury. The question requires us to find the height of the block above the mercury level. Of course, for us to be able to find the height of the block above the mercury level, we need to know the height of the block that is embedded within the mercury level. But still, we shall use the law of flotation to help us interpret this. Like we had earlier stated, the law of flotation states that the weight of the block is going to displace an equivalent weight of the mercury. In other words, as this block is floating, its weight is going to be equivalent to the amount of mercury it's going to displace. So we shall begin from that point, that the weight of the block is equal to the weight of the mercury displaced. So of course the weight of the block is given, what we're looking for here is this height. So definitely the weight of the block here is given by the mass of the block, multiply that by the gravity, is given by the weight of the mercury displaced, which is going to be given by the mass of the mercury, multiply that by the gravity. Of course, we are having gravity here and gravity here. This g and that g can as well cancel out at that stage because it's 9.81, 9.81. So what is the mass of the block? The mass of the block is given by, we know from the formula, density is equal to mass over volume. So if you make mass the subject of the formula, mass is given by density times volume. So the mass of the block is given by the density of the block, multiply that by the volume of the block. This is still going to give us the mass of mercury, which is given by the density of the mercury. Let me call this M. The density of the mercury, multiply that by the volume of the mercury. Now the volume of the mercury we are talking about here is the volume of the mercury that has been displaced. So this is going to be given by, of course now we know the density of the block, we know the volume of the block. The block is such that it is having 12 everywhere. It's a cube, each side is 12 centimeters, so it means that we have the length, the width, and the height of the volume of the block. It is given. That is going to be equal to the density of the mercury, which is also given, 13600 kilograms per meter cubed. Multiply that by the volume of the mercury. Now the volume of the mercury is the volume of the mercury that has been displaced. The density of the block, multiply that by the volume of the block, is given by the density of the mercury, multiply that by the volume of the mercury that has been displaced. Now the volume of the mercury that has been displaced is equivalent to the volume of the block that has sunk in. Remember, this is a floating body. When it is floating, not the entire volume of this cuboid is going to float inside. Part of it will float, will sink into the mercury, part of it will remain out. So to find the volume of the mercury that has been displaced, the volume of the mercury that has been displaced is equivalent to the volume of this cuboid that has sunk into the mercury surface, that has displaced. So it means that to find the volume that has actually displaced or that has gone into the surface of this mercury level, it is as simple as getting the cross-sectional area of this cuboid, multiply that by the height that has sunk into the surface of mercury. So the volume of the mercury that has been displaced is equivalent to the cross-sectional area of this cube, multiply that by the height of the mercury, or the height of the block that has sunk in. So to get the height that has sunk in, let's call it H1. So you make H1 the subject of the formula. So this becomes H1 is going to be equal to the density of the block, multiply that by the volume of the block, divide that by the density of the mercury, multiply that by the cross-sectional area of that cuboid to get the height of the block that sank into the surface. So in this case, the density of the block is given in the question as 7.8. Of course, this is density of the block, or the density of the solid block, given by 7,800. Now this 7,800 is in kilograms per meter cubed. Multiply that by the volume of the block, Of course, the volume of the block, it is 12 centimeters all through, so it is 12 times 12 times 12. Let me repeat this here in a bigger space. So this is going to become, the density of the block is 7. Divide that all by the density of the material, which is 13600. This is in kilograms per meter cubed. Multiply that by the area. Now the cross-sectional area of that cube is 12 by 12, and this is in centimeters squared. And of course here our answer for our H1 is going to be you realize that all those things cancel out. You remember, even these units, kilograms per meters cubed, cancel out with kilograms per meters cubed. So you remain that your height is going to be in centimeters. Now, of course, we were multiplying this kilograms per meters cubed by centimeter. Somebody would argue that would have to first convert this to meters cubed. It would still work out. If you were to convert this to meters cubed, it would mean that your answer here would still be in meters. But here we've done it in such a way that the kilograms per meters cubed are cancelling out, and we remain with figures that, and the units here are, we are getting our answer in centimeters. So the answer we are getting here is 6.88 centimeters. Now that 6.88 centimeters, this height we are getting is actually the height that of this solid that sunk in the surface of the mercury. But the question is not requiring us to find this height. If you go back to the question actually wants us to find what is the height of the block above the mercury level. So this is the height of the block that has been embedded into the mercury level according to our diagram here. So to get this remaining height, we know that this entire height is actually 12 centimeters. So to get the height of the block above the mercury level, the real height that they want is going to be equal to 12 centimeters. Subtract that 6.88. And when we subtract that, our answer here is going to become 5.12 centimeters. So 5.12 centimeters is actually the height of this mercury block that is above the mercury level. This question says that an object floats in seawater of density 1.03 times 10 to the power 3 kilograms per meter cubed, and it displaces 200 meters cubed of seawater. Find the mass of the object. Again, we are going to use the law of flotation, which simply states that the weight of the displaced seawater is the same as the weight of the object. So the weight of the displaced seawater is the same, or it's equivalent to the weight of the object that is actually floating. So now, of course, the weight of the displaced seawater is given by the mass of that displaced seawater. Multiply that by gravity. That is going to be equal to the weight of the object, which is given by the mass of the object. Multiply that by gravity. Of course, from here you see that the gravity and the gravity will cancel out. We have the mass of the water. Of course, mass of water is given by density of water. Multiply that by the volume of that displaced water is going to be equal to the mass of the object. The question wants us to find the mass of the object. So this is what we want, the mass of the object. So for us to get the mass of the object, we get the density of the water, which is 1.03 times 10 to the power 3. Multiply that by the volume of the water that has been displaced. Now the question says that it displaces 200 meters cubed of seawater. So it is 200 meters cubed that was displaced. That is equal to the mass of the seawater. And from this calculation, you find that our answer will be, the mass of the seawater will be 206,000 kilograms. Plus block of mass 500 grams and density 2.5 grams per centimeters cubed floats in a liquid with 18.5% of its volume submerged in the liquid. Calculate the density of the liquid. Again, we are going to use this principle of flotation to interpret this. We are looking at a glass block, and this glass block is submerged in a liquid. So what does that mean? It means that the weight of the block is equivalent to the weight of the liquid it displaces. So the weight of the glass block is given by the mass of the glass block, let me call it mass of B, multiply that by the gravity is given by the weight of the liquid displaced, which is given by the mass of the liquid displaced, multiply that by the gravity. So we go ahead and find, of course, the g's are going to disappear. Then you find that the mass of the block, or the mass of the glass block, is 500 grams according to our question. So it's going to be 500 grams is going to be equal to the mass of the liquid. Now remember that we were interested in finding the density of the liquid. So the mass of the liquid is given by the density of the liquid, multiply that by the volume of the liquid. So to continue with our calculation, this is 500 grams is going to be given by, now the density of the liquid here is what we are looking for, multiply that by the volume of the liquid. Now here we are looking at the volume of the liquid that has been displaced. Of course, the volume of the liquid that has been displaced has not been given to us directly in the question, but we know that the volume of the liquid that has been displaced is equivalent to the volume of the portion of the solid that was actually submerged. So we just need to look for the volume of the solid that was submerged. And according to this here, we are being told in the question that 18.5% of its volume was submerged in the liquid. So 18.5% of the volume of this glass block was what was submerged. So it means that the volume of this liquid that was displaced is equivalent to 18.5% of, this is equivalent to 18.5% of the volume of the solid that actually got submerged, which is in this case, let me call it volume of the solid. So it is 18.5% of the volume of the solid. So now what is the volume of the solid? We know that the formula for volume of the solid can be gotten from, still our question, if we know that density is equal to mass over volume, so it means that volume is going to be given by mass over density. We have the mass of the glass block being 500 grams, and we do have the density of the glass block, which is 2.5 grams per centimeters cubed. So it means to get the volume is going to be, we shall say 500 grams is going to be equal to the density of the liquid, multiply that by 18.5%. Of course, 18.5, this is 0.185. Multiply that by the volume of the solid. The volume of the solid is given by the mass of the solid, which is 500 grams. Divide that by the density of the solid, which is 2.5 grams per cc. 2.5 grams. So of course, when we make this the subject of the formula, we shall end up with our answer being 13.51 grams per centimeters cubed. And this is the density of the liquid. A cross-sectional area of a ferry and its waterline is 720, that is at its waterline. A cross-sectional area of a ferry at its waterline is 720 meters squared if 16 cars of average mass 11,000 kilograms each are placed on board. To what extra depth will the boat sink in water? Again, this is a ferry and it is floating on top of water. And the principle is simple, that the weight of the water displaced is equivalent to the weight of the entire ferry. Let me try to draw this diagram. This is the ferry right there. And this is the water line we are talking about. Now the question is telling us that the cross-section area of the ferry at its water line, so while it is there, this is the water line, so the cross-sectional area there is 720 meters squared. So now if 16 cars of average mass 11,000 kilograms, so it means that you're going to put 16 cars and each car is 11,000 kilograms. to what extra depth will the boat sink. Of course, if this boat is to sink any extra depth, it means it's going to displace some water. And if it is to displace that water, the weight of that water that is displaced is going to be equivalent to the weight of these 16 cars that were put on the ferry. Why? Because it is these 16 cars that are responsible for this boat to sink that extra depth. So our work here is simply to find we simply need to just identify the fact that these 16 cars are the ones that are going to be responsible for this ferry to sink down an extra height or an extra depth, and so therefore the weight of these 16 cars that was put on this ferry is going to be equal to the weight of the fluid that will have been displaced at sea. So we begin with our calculation at that point. That weight of the water displaced is equal to, and of course what is responsible for the weight of this ferry? It is these 16 cars that were added. So let's go ahead and find the weight of the water displaced. Of course the weight of the water displaced is given by the mass of the water, multiply that by gravity. That is given by the weight of the ferry, which is comprised of the mass of the ferry, multiply that by gravity. Of course these values of G will cancel, we remain with mass of water. The mass of water is given definitely by the density of that water in the sea, multiply that by the volume of the water. That is given by the mass of the ferry. Now for the mass of the ferry, according to our question, they are putting there 16 cars, and the average mass of these cars is 11,000 kilograms. So it means this is going to become 11,000 kilograms. That is the mass of each car, multiply that by 16 cars. That is the mass of the ferry. That's the cars they add, and they are responsible for the water we are trying to find. So the density, this becomes density of the water, multiply that by the volume of the water that has been displaced. The volume of the water that has been displaced is going to be given by the cross-sectional area of the ferry, multiply that by the height that sinks in, the depth that is sinking in as a result of these 16 cars that have been added on the ferry. So that is going to be equal to 11,000 times 16. So we're interested in this height because the question is asking that what extra depth will the boat sink in water? So the boat is already in water, but there's an extra depth it's going to sink, and that extra depth it is sinking, which we are calling H, is as a result of these 16 cars that they've added. So we make H the subject of the formula here and find that extra depth. So that extra depth H is going to be equal to 11,000, multiply that by 16, divide that by the density of water, multiply that by the A. Of course this is 11,000 times 16 cars, divide that by the density of water, which we all know to be 1,000, multiply that by the cross-sectional area of the ferry, which is 720, and we shall end up with our answer being 0.024 meters. So the ferry sinks an extra 0.024 meters as a result of those added cars. A solid weighs 237.5 grams in air and 12.5 grams when total immersed in a fluid of density 900 kilograms per meter cubed. Calculate the density of the liquid in which the solid would float if a fifth of its volume is exposed above the liquid surface. If I may summarize this question, we are talking about a solid here. This is here. The question gives us some of it, the information of its mass. This solid weighs 237.5 grams in air. So this is its mass in air. So its mass in air is 237.5 grams. And then its mass when it is totally immersed in a fluid is 12.5 grams. And they're telling us that the density of this fluid is 900 kilograms per meter cubed. So calculate the density, the density of the liquid. So this is when this happens, as in it was going to, the mass of the fluid will be, the mass of this solid when it is in a fluid will be 12.5 grams when it is immersed in a fluid of this density. And now the question is asking us that what is the density, or calculate the density of the liquid in which the solid would float. So let's say this is the liquid we are talking about. So they want us to find the density of the liquid in which this solid would float if it had a fifth of its volume exposed above the liquid. So if we are having a fifth of this exposed, what would be the density of this thing? Of course, if it's a fifth exposed, it means below here it is 4/5. So here, below here, it is 4/5. 4/5 of the body is submerged, and a fifth is what is exposed above the liquid surface. And definitely, of course, now we are supposed to find the density of that liquid. So of course, still we are going to use the law of flotation, that the weight of this solid is going to be equivalent to the fluid, the weight of the fluid that has been displaced. So we will begin off from that point and say that the weight of this solid is the same as weight of fluid displaced. Let me call it liquid, because this one we've referred to as subscript L, weight of the liquid displaced. So what's the weight of the solid? Of course, the weight of the solid is mass of the solid mass of solid times gravity is given by the weight of the fluid of the liquid displaced. So it's going to be the mass of the liquid, multiply that by gravity, and of course the gravities will cancel out, you remain with mass of the solid. Now of course we have the mass of the solid, which you are calling the mass of the solid when it is in air. It is 237.5 grams. So we already have the mass of the solid, but then the mass of the liquid, we need to break this down further. So mass of the solid is given by mass of the liquid. Now for mass of the liquid, mass is given by density of that liquid, multiply that by the volume of that liquid. And so this means that mass of the solid is going to be given by the density of the liquid. Remember, we are looking for the density of that liquid that they are asking. That's what the question requires. The question is asking us that calculate the density of the liquid in which the solid would float with a fifth of its volume exposed. So this is the density we are looking for of that liquid. The density of the liquid, multiply that by the volume. Of course, the volume of the liquid that was displaced here is 4/5 of the volume of the body that was submerged. So it means that if you get 4/5, 4/5 of the volume of this solid that was submerged is equivalent to the volume of the liquid that was displaced. So it means it's going to become, multiply that by 4/5 of the volume of the solid. So now the thing is that we need to find the volume of this solid. We do not know the volume of the solid because we have the mass of the solid. We do not have the volume of the solid, but we knew the question requires us to find the density of that liquid. So our agenda now, we need to find the volume of the solid so that we come back and put it there. Maybe we can call this our first expression. So now we need to go ahead and find the volume of the solid. But how do we find the volume of the solid? We need to find the volume of the solid. We need to look at the information that has been given. From the information that has been given in the question, they've given us this, that when this solid is submerged in a fluid of density 900 kilograms per meters cubed, its mass is going to be 12.5 grams when it is submerged, and when of course the solid is in air, this is its mass. So given this information, this can help us to find the volume of the solid. If you look at this information, we can use Archimedes' principle. Remember, we were able to obtain this expression, using the law of flotation. Now let's use Archimedes' principle using this information that we are given to see where it lands us. Now, from Archimedes' principle, we know that upthrust is equal to weight of fluid displaced. From our question, upthrust, we've been given the mass of this solid when it was in air, the mass of this solid when it was immersed in the fluid whose density was 900 kilograms per meters cubed. Now the upthrust, of course, it is mass in air minus mass when the solid was immersed in the fluid. So in simple terms here, upthrust is going to be the mass of that solid when it's in air minus its mass when it's in the fluid. In other words, this upthrust, this apparent loss in mass, is equivalent to the upthrust. So mass in air minus mass of the fluid is going to be equal to the weight of the fluid displaced. Of course, this is mass in air minus mass in fluid. We shall multiply that by gravity, because here upthrust is equal to weight of fluid displaced. So, but the figures we have here are in grams. This is mass. So to convert them to weight is this mass times gravity. This mass, converting that to weight, is mass times gravity. So it's the same as saying the mass in air minus mass of when it is immersed in the fluid times gravity. This is the upthrust. Is going to be equivalent to the weight of the fluid displaced. Now the weight of the fluid displaced still is going to be given by the mass of the fluid, multiply that by gravity. Now of course the G and the G will go, they will cancel out, and so we shall remain with mass in air, which is 237.5 minus mass of the solid in fluid, which is given by 12.5 grams, is given by the mass of the fluid that was displaced. Now the mass of the fluid that was displaced here is still given by the density of that fluid, multiply that by the volume of that fluid. Of course, now this is going to give us 225 grams is equivalent to the density of the fluid. Now, according to our question, the density of the fluid is 900 kilograms per meters cubed. So this is going to be 900 kilograms per meter cubed. Multiply that by the volume of the fluid that was displaced. Now you realize this is in grams, this is in kilograms per meters cubed. It's only safe to convert this to kilograms as well to harmonize the units. So to convert this to kilograms, we shall divide by 1,000, so that this is also turned into kilograms. So now we make VF the subject of the formula. You find that the volume of the fluid shall be given by, in this case, it is 2.5. Multiply that by 10 to the power negative 4. That is meters cubed. So what does that mean? It means that we have found the volume when this solid was immersed in the fluid whose density was 900 kilograms per meters cubed. We find that the volume of the fluid that was displaced was equivalent to 2.5 times 10 to the power negative 4 meters cubed. But remember, when we talk of this being the fluid that was displaced, this fluid we are talking about of 900 kilograms per meters cubed, the question tells us that a solid weighs 237.5 grams in air and 12.5 grams when totally immersed in a fluid. So by the time it was immersed in this fluid of 900 kilograms per meters cubed, the question says it had been totally immersed. So it means if it had been totally immersed, and our calculations here is saying we have discovered that this is the volume of the liquid that had been displaced. It only means that the volume of the liquid that has been of the fluid that had been displaced is equivalent to the volume of the solid. So this means that the volume, this 2.5 times 10 to the power negative 4 meters cubed, is the same as the volume of the solid. So we shall simply write a statement and say that volume of fluid displaced in this case. So now that we've got our volume, the volume of the solid, so now we go back to our original expression. It means that we are going to get the volume of this and place it right there where we had stopped last time. So For us, we're interested in finding the density of the liquid, so it means to get back to this expression, we shall say, if I may rewrite it, the mass of the solid is giving us the density of the liquid. This is going to be equal to, so the mass of the solid in this case here is 237.5 grams, but convert that to kilograms by dividing by 1,000. Is going to be equal to the density of the liquid, multiply that by 4/5 times the volume of the solid, which is this 2.5 times 10 to the power -4. So the density of the liquid in this case is going to become 1,187.5 kilograms per meters cubed. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.